Hi, today I would like to talk about Deflex. My riser has a lot of Deflex and I want to explain how I got to that. What is Deflex? It is the distance of the throat of the grip in front of the limb pockets. You have Deflex, you have inline where the grip is in line with the limb pockets, and then you have Reflex where the grip is behind the limb pockets. Now why is Deflex so important? I mean, it is important to me because I like it and I like how it feels. Every bow that I've shot that has a grip that was placed far forward felt good to me. It felt easy to shoot, it felt stable. So when I set out to design this, I, um, I figured out how to place the grip as far forward as I could without losing the brace height, and making all the angles still work. So what actually happens if you look at this strung bow is in nature, every action has an equal and opposite reaction. So all the force that comes and pushes the arrow forward will come back into the bow, into the riser. So if there's an instability, it'll be amplified by the riser. So by placing this grip far forward, it almost acts like a rudder, kind of like a stabilizer. Like if I pull back, it doesn't, if I was pulling it back like this, there could be a lot of torque in the bow. Whereas like this, it's almost, self-stabilizing. It's almost like if you watch somebody walking on a tightrope, they're balancing it like this. They're not balancing like this. That would be a lot harder. So if I would shoot this bow, with the grip behind, and the force coming back would want to flip the bow around, or at least amplify whatever, instability is going on with me holding the bow. So that's all very exciting to me. And all right, let's get into this. I made this drawing to make it even more clear, and this drawing is 1-to-1, so it's a great representation of what we're talking about here. When I set out to design this riser, I wanted to keep everything very clean, simple, whatever's there. It's almost like the design explains itself. So what is Deflex in this drawing? It's basically the distance between the throat of the grip and then the contact point of the limb pockets. You can kind of see it touches the front of the pocket right here where the actual limb slides into. And for the 19-inch riser, it's 1.75 inches or 44 millimeter. For the 17-inch, it's 1.42 inches or 36 millimeter. And then for the 21-inch, it's 2.05 or 52 millimeter. Now this whole design, as you can see on this drawing, is perfectly symmetrical. There's a center line right here, and it's split perfectly 9.5 inches this way, 9.5 inches this way, and the bottom mass of the riser is 391 grams, and the top mass is 385 grams. I set out to be exactly the same. I got it within 6 grams. I think that's pretty good considering. Other information on this drawing is the center of gravity is running right by the center line, a little bit off to the right. On the front view, it's 0.16 inches. And then for each riser, 17, 19, 21, these are the dots representing where the center of gravity is. It's right behind the grip, but it's still within your hand position of the grip. And there's a little bit more detail drawing right there, and I'll make this drawing available on my website so you can print it out and look at it in more detail. But anyway, and these gravity points are basically, what this represents right here. So this dimension is actually represented right here, and it kind of shows how well balanced this riser is, top to bottom, left to right. I hope you enjoy this. I like making this drawing, and let's move on. So let's talk a little bit about balancing. A lot of people always go, it falls back in my hand. at this point, it is what it is. You can add a weight to this to balance it. But in the end of the day, like somebody once told me, a bow is just a bow. It's got to work for you. You know, this might not work for you. So therefore, don't use it. Because of the Deflex, this sits perfectly balanced like this. But that doesn't really tell you anything either. You know, like, will it shoot well because it's balanced like this? Will it not shoot well because it's not balanced like this? So there's a true test where you kind of like try to balance it, you know, vertical and horizontal, where you're kind of holding it like this. When I designed this, I really wanted this to be purely symmetrical, where the throat of the grip sits right in the center of the bow. These limb pockets are the exact same distance, and the mass of the top and the bottom are almost identical, so that the force coming back, you know, gets absorbed equally into the riser. So let's see how each of my risers are balanced. So I designed this, start with the 17 inch. So I designed this contraption where I can modify the screw and find the true balancing point. And as you can see, you know, this is like perfectly balanced, you know, left, right. It's down the center of the, you know, right at the center of the bow. And so that means the mass top and bottom is equal. And this is the same for, you know, the 21 inch. It's basically a little bit further back, but it's still right into your grip of the bow. But they're all equally balanced like that. And then there's the 19 inch, same story. And the drawing kind of shows where all these pivot points are. I marked them on there. But yeah, I thought this was cool, that how these risers came out, because you can design it, you know, with all the best intentions using CAD and analyze it, and you know, but there's still, at the end of the day, the materials, you know, the weight, everything's got to work. So that's the story behind the riser. I hope you kind of enjoyed that. I'm gonna try to do like slow motion shooting, so you can kind of, you know, maybe see this vibration coming back through the riser. But we'll see. All right.